Hi, this is Video Explainers for week 3. I'm going to be explaining a problem from Mastering Physics Homework 2, specifically problem 12.1. So problem 12.1 states a high-speed drill reaches 2200 revolutions per minute in 0.53 seconds. And so I drew a figure to represent what is going on. And so I represented the drill as like a circle since it is experiencing circular motion. And so this problem primarily deals with angular acceleration and how that can contribute to how many revolutions this particular system undergoes. And so angular acceleration is a vector, and it accelerates. In this particular case, it represents this type of circular acceleration where it accelerates around the circle or around the center of the circle, and we're denoting angular acceleration as the alpha variable. So part A states, what is the drill's angular acceleration? So first, we're going to be converting the 2200 revolutions per minute into revolutions per second, so then we can easily convert it into the angular acceleration. So it states that there are 2200 revolutions in 1 minute, and in 1 minute there's 60 seconds, so that means there is 36.67 revolutions per second. And then we can multiply the revolutions per second by 2 pi to get the value into meters. And then we can divide that by the 0.53 seconds because that's what is stated in the problem. And we get an angular acceleration of about 434.73 meters per second squared. So part B states, through how many revolutions does it turn during this first 0.53 seconds? So in order to find that out, we're going to be using this equation. So the revolutions equals the initial angular speed times the time plus 1/2 times the angular acceleration times time squared. And since we're going to assume that the initial angular velocity is going to be 0, this first term is going to cancel out, leaving us only with this term. And so I plugged in the variables for alpha. We're going to be using a more approximated value of about 430 radians per second squared. And then we're going to be using 0.53 seconds for the time, and we're going to square that value since that is the equation. And so we got a value of 60.3935 radians. And so in order to convert that into number of revolutions, we're going to do this conversion. So there are 2 pi radians per every revolution, and I got an answer of 9.6 revolutions. So yeah, this problem primarily deals with angular acceleration and also determining how many revolutions there are in a certain set of time. And we're using equations that involve angular velocity, angular acceleration, and we're also acknowledging that there are 2 pi radians per every revolution. I think that the tricky part about this problem is that knowing when to convert the variables can be tricky because I feel like it's tempting to convert all of the variables towards the end, but I think in this case it works better if you convert it firsthand, so you can just cancel out all the correct variables and get to the correct answer at the end. And then also knowing when you have to divide or multiply by 2 pi radians because that can be slightly tricky at first. Right, thank you.